basically shear stresses design approaches in RCC beam. In my last video, I talk about the introduction part of shear, how the shear is generated in the RCC beam due to bending moment. So in case you missed this video, there is some I button or you find their playlist, go and check out. Okay. Hello friend, I am Samyadeep back to with new tutorial video regarding shear stresses in RCC design. Okay. So before start this video, let me show you one thing. These shear stresses approaches, there is two types of approaches. One is as per elastic theory approaches and another is your IS 456, in short IS code approaches. Okay. So there is two types of theory. So first we discuss the elastic theory. Second we discuss the IS 456 code design theory. Okay. So first I describe the elastic theory. This is your beam section. This is your loading diagram. This is compression. This is tension. From this actual shear stress diagram like this. If this is your neutral axis, first it is kind of parabolic, then it is straight rectangular. So this is actual your shear stress diagram in your RCC beam. This is a kind of very complex for designing part. So first let us understand the elastic theory. From this particular point it is your parabolic as per elastic theory, and from this part it is rectangular. So shear stress diagram is combination of parabolic and rectangular. Okay, this is the value of the minimum value I write here, minimum value in compression zone, maximum value tension throughout the section except the maximum compression zone throughout the section and from this elastic theory the Q that is equal to V by BJD. This is the elastic theory shear stress formula. What is J? J is this a constant. So here V is your shear force, B is the your breadth, D is the depth, and J is your lever arm depth factor. So this is the shear stress as per elastic theory. But now I discuss the IS code approaches. As per IS code, that is 456/2000, due to simplification, due to easy calculation, we simplify this. Q equal to V by BJD, that convert in tau equal to V by BD. For simplification, that J term is missing, and this tau is known as your nominal shear. Why nominal? Because actual shear stress is look like this, but this BD is showing a rectangular. That means here this is like this. So this is from your elastic theory. This is from IS code theory. Okay, and elastic theory to IST, this is the conversion change. So now why it is called nominal shear? Because if I superimpose this section to this section, then that will be like this. So from this is your drawing from your elastic theory. Now we superimpose the IS code drawing. So we actually added this extra more and we deduct this value, and ultimately we find this. That is why nominal normalizes, we normalize the whole value, that is called nominal. That is why tau equal to V by BD. Yeah, okay. So this is the two approaches where I mention this elastic theory, that is the actual concept, but due to simple calculation part we go for the IS code value method, where we convert this actual formula to simplification formula as a nominal shear. So here it is the main diagram. So yeah, if you have find any kind of doubt, one more thing, this is your final shear stress distribution diagram. ठीक है? Okay, so yeah, if you find any kind of doubt, do comment in comment section. I will definitely get back to you. And if you find some value related to this video, then definitely like the video, and yeah, subscribe this channel for getting more this kind of content, and definitely share this video to your friend circle. Okay, and yeah, in next video I will talk about the effect of shear on RCC beam. Okay, so yeah, till then, bye bye, take care, and yeah, thank you for watching this video.